Thorium is built with a single centralized server that connects to multiple clients over HTTP. We're going to talk about the server's architecture first, and in the next video I'll explain how the client works. The server runs all of the processes for Thorium, including the web server, the API server, WebSocket communications for the subscriptions, and background processes. All of the data for Thorium is stored in a massive object called app inside of the server source app file. App is where you'll find any data about any simulator, about missions, systems, or anything else that's stored in Thorium. It's just stored in one of these lists here on this app class. When Thorium first starts up, it searches for a file in the data folder called snapshot.json. When we're in development mode, it finds it inside of the Thorium code repository, the code folder. If we're using the built version of Thorium, it lives inside of the documents folder and then right here in the Thorium folder. There's that snapshot. This file is the persistent storage for Thorium, kind of like a database. When Thorium isn't running, you can view and modify that file to change any of the data about Thorium. This file is updated whenever Thorium changes any of the data in app. Thorium also starts up a number of other background processes through this bootstrap process. So when the server first loads, it grabs all of these files from the bootstrap folder and then runs them all in order to set up Thorium. One of the things that it does is it sets up the broadcast, which uses Bonjour to broadcast this service to the network, which makes it so that the clients can automatically connect. It starts up the Express server, which handles some of the import and export functionality of Thorium. It starts up the Apollo GraphQL server by grabbing all of the GraphQL data from the typedefs folder and starting it up and loading it. And it also starts up any background processes. These processes live in the processes folder, and these are processes that run in the background to update things like heat, sensor contact location, or anything else that needs to be processed in the background. As you might know, the GraphQL server handles all of the queries, mutations, and subscriptions that Thorium's client needs to read data, update data, and be notified about changes to data. All of Thorium's GraphQL resolvers operate in about the same way. Let's take a look at the one for phasers by going in the typedefs folder to phasers. We can see that we define the type for phaser here and the other types that might be necessary for the queries, mutations, and subscriptions. Down below is where we extend query. This gives us the actual API that we can use to access phasers or an individual phaser. We extend the mutation, which is all of the operations, the actions that can be performed on phasers, and then this subscription, which allows us to subscribe to updates about phasers. Down below that is our resolver, where we have a resolver for our phaser type, and then resolvers for the query, right here, where we can query by phasers and get all of the phasers in a specific simulator, or we can get a single phaser by ID. We've got our mutations, which use this mutation helper, and then we have our subscription that has this resolve function to modify or update the data before it's sent out to any subscribers, and then we can also filter it by if there's anything there. So by filtering the subscription, we can choose whether or not a subscriber should get access to that. For example, in some cases, if you subscribe with a simulator ID, then you won't get any subscriptions about items that aren't related to your simulator. Like I said, pretty much all of the type definitions in this typedefs folder follow the same pattern where the schema is up here, it extends query, mutation, and subscription, and then it provides the resolver for the type. For the query, it uses the mutation helper, and then it provides the subscription. Let's talk about this mutation helper. Thorium operates on an event-based system. All mutations trigger events by calling app.handleEvent. So we can take a look at that by going into the mutation helper here. We can see that it takes the schema and it pulls out all of the mutations, and then it creates a function for those mutations which calls app.handleEvent, and that's what actually handles the mutation. So if we go back into app, the handleEvent method grabs a timestamp, gets information about the client that triggered the mutation, creates an event object and adds it to an event log, and then it takes care of some other stuff before finally emitting the event as an event to app. This can be picked up elsewhere in the application. In our case, it's picked up in the events folder. So we can look at all of the mutations or the actions that are performed by the mutations inside of this events folder if we find the phasors object. So for example, if we were charging our phaser beam, we can see here I do app.on and then the name of the mutation. These are the arguments of the mutation, and then this is the action that it performs. This first line grabs the system out of app.systems. Remember, this is the database, and so in order for me to get the data, I have to pull it out of the app database. Then I take that system and I perform an action on it. I call this update beam state method, and that sets the beam to be charging. And then I have to trigger the subscription to let all of the clients know that a change has been made to a phaser system. So I call this subscription. Now here's a question: where does this update beam state method come from? Well, each item, each object in Thorium is defined as a class. So now we're getting to the actual heart of Thorium. These classes here in the classes folder define what properties are on an individual object and methods that can be called on that object in order to perform actions in order to update it. So we can see here that the set beam state, this update beam state, is going to find any of the phaser beams, since you can have one or more phaser beams. It's going to find that phaser beam, and then it's going to call update state on it in order to make it charging or firing or discharging. So almost all of the logic that an object in Thorium will have will reside inside of this classes folder. The processes folder holds some of the logic as well. So let's take a look at the phaser process. Since phasers charge in the background, once you've clicked it, it'll automatically charge up. We're going to have a process that runs. We've got this update phasers, and this process runs to charge the phaser beams here, and we call a set timeout on it in order to have it run automatically. So it's going to be continually calling itself in the background, and then we call it once here. And this just takes the current state and changes the charge level and the heat level depending on that state. And then we have another one that actually cools the phasers down slowly over time. That's all for the back end, and watch the next video to learn how the front end works.